Hello, I did a little bit of recording when I went to pick up the plates from Nalco and also when I took it to the water jet place to get cut. So I thought I'd just show some of that for this video.
Okay. Oh, look at that. What's the biggest sort of thickness that you deal with here? I see you got pretty big stuff around.
300.
Oh, shit. Hey. It's pretty hefty.
Here are the CAD designs of the two plates that I had cut, and as I said before, the only reason this was in two separate plates is because I had one of them cut when I picked it up so that it would fit into the CNC machine, but that turned out to be not necessary, so it could have been one plate and the water jet could have done it just as easily. So this is the bottom plate, and then the rest of the plates were in the smaller piece, and I had to add little tabs between them, not necessarily so that the jet could cut them properly, but trouble is they would fall into the water bath below, and apparently there's lots and lots of sand built up below there, and they would just fall into the soft sand and be impossible to find. So I added these little bridges here and cut those with the hacksaw afterwards to separate all the pieces. The water jet cutting place that I went to is in Hamilton. It's called ProCut NZ, and it's run by a guy called Morris, who was very, very helpful and very, very fast at getting me a quote and helping me out with ideas about how to make my design so that it wouldn't fall into the water and so on. This place, they do a lot of these sulkies. It's a bit of a funny name, but it seems like this thing here that goes behind the horse when you're doing harness racing like this is called a sulky, apparently. And so they do a lot of custom built ones of those, and they use the water jet to make the wheels and some other parts as well, like the clamps. So anyway, this is where I took it, and let's have a look at that.
For some reason, what it'll do is it'll go along and find the holes in that line. It just go up and down
Right.
as it goes along.
This water is forced out under 60,000 psi of pressure, and it's mixed in with a little bit of garnet, or a sort of a very fine sandy stuff, and that's what is the abrasive that cuts through and makes the hole. And it's powered by this enormous pump here. I think it's a big electric motor which powers some hydraulic fluid, oil I suppose, and then right above it there you can see two pistons at the top which are taking turns being pushed in to force the water into the final tube. I stuck my GoPro onto the gantry of the machine while it was cutting, and unfortunately right at the beginning it got a little bit of sand splattered onto one part of the screen, but fortunately we can sort of see right in the center still, so I'll just show you a little bit of footage of that, sped up of course. Cutting anything, I mean, it's
Yeah.
goes pretty quickly.
I think that's where I sort of miscalculate. You're measuring it in metres, but every hole means a lot longer and a start and a stop on each time. You can take those home and just double check everything. That,
Get started with the tapping.
Yeah, just double check and make sure that the holes are suitable. There's one that's sort of missed. It probably just failed to bring abrasive through.
Is that this when it starts the hole, it didn't quite make it all the way through? Or?
It's missed it right through there somehow. Now, that's not common, but I have had it before.
Yep.
And I would say it just probably a bigger grit of abrasive has come through and just didn't allow it to finish off. And then when it goes across and does another bang, it's probably been able to push that through.
Right.
And it just
I have the outline of the hole, so it should be easy to drill through.
Yeah.
Yeah. So that all went nicely according to plan. It's not quite the accuracy that CNC machining would have given, but for what I'm doing it should be good enough. Here you can see some of the cut-out sides of the thing. You can see it's all nice and sharp and straight and everything. And the holes are all in the right places, of course, right in the correct diameters. One thing that's not really ideal is that the walls of the material are not perfectly perpendicular to the surface of it. So maybe you can see in this photo, I'm trying to take a photo of it, but it's quite difficult. But on the left-hand side, you can maybe see that that's sort of sloping a little bit. And that's a consequence of the water jet being... It just takes a bit of time to sort of burn through the material. And you apparently can improve this by leaving it running for longer. But for pretty much all of the edges on my plan, it's not going to be an issue. There is just one edge which I would have liked to have had perfectly perpendicular, but this level of slope is not really an insurmountable problem. I can probably just file it down a bit or sand it down and it will be perpendicular enough. Anyway, all that kind of cutting and drilling and tapping and sanding and stuff like that will be in the next video. So that's where this one is going to finish. Thanks for watching.